Hi, everyone, and thank you for joining us today. My name is Victoria. I am Employer Brand Event Specialist at Intellias. While we are waiting for some participants, I'd like to tell you a few words about our company. Intellias is a global technology company with over 3,200 specialists on board. We combine engineering craftsmanship and technology expertise to solve challenges of any nature, scale, and complexity. Our development centers are located in Poland, Croatia, Bulgaria, Ukraine, Spain, Portugal, Colombia, and India. We also have representative offices in Germany, the USA, the UK, and the United Arab Emirates. So, a few organizational moments. Firstly, let's do our webinar in the dialogue format. So you can put your questions to a speaker here in YouTube chat. Our moderator will read them and Taras will answer ongoing. One more thing, we will send you email with the webinar recordings, speaker's presentation, and feedback form tomorrow. We highly appreciate your feedback and it will help us to improve our future events. So before we start, let me introduce Oleg Heric, a Golang engineering lead at Intellias for introduction award, and he will be our moderator today. So Oleg, please go ahead.
Okay, so yeah, my name is Oleg. I'm head of Golang unit in the Center of Excellence in the Intellias. And no, I'm not a speaker today, but I have a small story for you. Traditionally, we have 2 times per year meetup in our shelter in our office, but unfortunately, this year we didn't have possibility to host this event. But as we want to invest our time to community, as we want to share our experience, and as we have awesome speaker with awesome presentation, it will be able to not share this information with you. So today I would like to present you our speaker, Taras Lushney, with awesome presentation, cross-language communication in the Go. And I hope you will enjoy. Just one reminder, please share your questions to the chat, and I will redirect all your questions and to our speaker. Taras?
Hi. Okay, yeah. Do you see my slides?
Yep.
Okay, cool. Yeah, today I would like to talk about the cross-language communication with Go as example. So yeah, I'm currently solution architect at Intellias. And yeah, today topics it's cross-language interoperability. So which allow to using different languages, combine them into one application, which is natively interact between different components in the applications and operate with shared data structure, etc. Yeah, mostly it's why we need it. It's usually when we try to call some low-level code from high-level languages and versus. Just some terminology. So if I be talking about the host language, it's like a primary language in your application, which like start your application. And then we can have like some guest language. It can be some scripting language if it's more high-level language, or it can be system language, which is if we would like to interact with some operation system. It's some like operation system low-level stuff. Yeah, actually, I personally divided languages for would like to say 3 groups. We have really some high-level languages. It's mostly scripting languages, not compiled. It's like some Python, JavaScript, Ruby, Lua, and then we have like some system languages, or which is called like low-level languages. each mostly languages which use for written some operation system and interact with the operation system. I always put it like a C, C++ there. We have like two modern languages like Rust and SWIG, which is now it's like a little bit a new language, and some old language like a Fortran. I put the Fortran because Golang natively support Fortran. And we have like some languages in the middle. Yeah, from one side, I'm not talking about it's like low level languages because it has like a garbage collection. You cannot like manipulate memory directly. But still, it's a compiled language and with pretty high performance. And yeah, this is the middle. And this languages have like a two opportunity. It can communicate with the low level languages, and also it can be used by high level languages as a low level language. And Go is one of this language. Yeah, just small agenda. I would like to share maybe my experience in this topic. Like a motivation when we will need to use different languages in a one application, and what challenges we will have when we using it. Also, I will mention about some main method of language interoperability, how it's used in a Go. And I would like to share some best practice of using CGO that I found when I using it maybe last 2-3 years in my Go project. Very short about me. Yeah, I am like a solution architect on Intellias with more than about 20 years of experience. And I have a chance to work with the different languages, different projects. Mostly have like a huge experience working with the C, C++, then Go, Python, and many other languages. Also have like experience working with many mobile stuff. And during this my life, I commonly use 2 or 3 different languages in one application. And this is just some list of my experience. Just would like to explain my motivation of using it. Yeah, first, it's maybe even started from university when I'm doing some home task, and we develop algorithm for image recognition, for cryptography, etc. But in this time, it was not very nice UI framework for C++, and it was really nightmare to writing any UI using C++. That's why I found that, yeah, it was appear .NET with C#. Also, it was appear Java 2, which have a pretty nice UI framework. And I start using it. I develop only UI using one of these languages. And business logic will be written in a C++. And it worked nice. According to my professional experience, when I come to first my project, I found it was common that we have a client-server application. It was written client, it always was C++, server was in the Java, but we had a lot of common code, like some algorithm, business entity, etc. And it was shared between these two products. And yeah, for Java, it was using GNI with C++, written in a C++, this component. And we actively use it during the project. Yeah, another very interesting experience, it was that we created plugins for applications. It was for rich web application and allows this plugin communicate with your local desktop application. And in this case, we use interoperability between the C++ and JavaScript. Okay, maybe next one, it's like, yeah, after that, I was mastered C++ UI, but in our project appears UX designer, and our UI become more rich, And yeah, we go with the solution that we, in our even C++ application, we embed UI as HTML, JavaScript. It was like even before HTML5. And yeah, this component was responsible for nice, responsive, animated UI. And then it communicates with our C++ code, mostly using like a COM technologies. And yeah, another purpose that our application, it was like a C++ compiled application, and we planned to provide some dynamic behavior in this application. And yeah, we provide scripting languages. It was like in first time it was AutoIt, then we switched to the Lua. And yeah, we provided bridge between the scripting languages and C++ applications. Yeah, creating a lot of library for it's for our automation projects. We have like automation in a different languages, like it was Python, Java, and like AutoIt and many another languages for automation. And it was a lot of requests that we need to some API which interact with the low-level system stuff, etc. And yeah, we create such kind of the API. It was mostly COM API, which allowed to use in a different languages. Another big my experience that I work at, then it's like a Python project where we have like a Python system development on Linux. And we have like a very tiny integration with the Linux operation system, authentication in the Linux, etc. And we found that pure Python was not enough for us. And in this application, we implement like a UI on the Python, like a client-server communication on the Python, but all low stuff was implemented in a C, C++, using like a Boost library for integration, etc. Then maybe it's a big part of my mobile experience. Yeah, when mobile appears, we do not have a lot of experience in Objective-C. And first, even mobile project, it was written in a pure C++, and then only UI was written in Objective-C. It was like in the past. And yeah, in the mobile, it was not a lot of library available. It was like a very small domain, and we use a lot of C++ library for Android development, which is mostly on the Java, and also iOS development, which is Objective-C, Swift, etc. This is, again, interoperability between the different languages. Big part is cross-platform development. One of my another big project was it's a map operation.
Taras, sorry for interrupt you. We see notification from Teams in your screen.
I put it focus mode. It's very interesting. Okay, yeah, sorry for that. Yeah, so we have like a big map operation system, which is mostly cross-platform. It was written in a C++. But this map operation system, as like SDK, used in a lot of different platforms. So it was some server which provide Java API, and it's communicate with the C++ operation system, SDK. It was Python also. This map operation system used on the mobile devices. It was, again, Java, Objective-C, Swift, etc. And maybe last my experience, it was related to the Go. So it was IoT project where we decided to develop in a Go, and we even decided to use Go in the Edge. It's pretty good, suitable for it. But we have like a part integration with hardware, with some data acquisition system, etc. And in this case, we integrate Go with operation system first. It was just good to use syscalls, but after that we use CGO for it. Then again, in the Go, one of our sub-project was to create a report generator in a PDF. And we found that there are no good matured library for generating PDF in a Go, but we have this library written in a C++. And again, we integrated in our Go project. And also, yeah, have some pet project, which is I use for sharing business logic between the different platform, like JavaScript, Golang. Yeah, it's again, inter-process communication. Yeah, just summarize motivation. So it's not done for fun, never done it for fun. But the main motivation for it, if you already have some library, usual library available in a C, C++, we have a lot of such library like a TensorFlow, different image conversion, video conversion, PDF generator, etc. And we need to use this library in your project or SDK. Another, it's access to the operation system. As I mentioned that sometimes that level, that operation provided by language is not enough. You need to use some maybe low stuff like a virtual channel, managing processes, etc. And yeah, it's mostly written in a low-level C code, which should be interoperable. Cross-platform development. Yeah, this is a very good topic because usually, it's even in my experience on pet project, I found that I have a classical client-server application where we have a server written in a Go, a client, it was JavaScript, and I found that mostly half of the code, which we have written in a Go and JavaScript, it's the same. It's a handle business logic, validation, handling request, response, etc. And it's a good chance that this code can be moved to another language. In one case, it can be even the Go. And yeah, compile it in a WebAssembly for using from JavaScript application. Yeah, another motivation is what I mentioned, providing a scripting in your compiled application. Sometimes you need some dynamic behavior. Yeah, in one case you can handle it by complex configuration, putting some complex JSON files, how application behave. But it's easily to just provide some scripting, provide a Lua access to this application, which you can change application behavior for already compiled application. And last but not least, yeah, use right language for right task. So I found, for example, Go is a very great language for writing microservices, web services. And maybe another languages like SWIG or Go, it's better for writing business logic. And team experience. Sometimes it's happened when you have a team which really have a good experience in a C++ and you start in development mobile application. It's happened in my experience, and that's why maybe this a mix of the languages can be a right choice. Okay, challenges. It's not free. Usually, different languages have a different representation of the types, data type, and you need to do all this mapping. Memory management. We have some application which have garbage collection, auto, memory management. In some languages, everything is manually, and we need to handle and have a bridge between it. For example, in a Python, we have a reference counting. In Go, we have a garbage collection. In C, we manage everything manually. Different language has a different paradigm for error handling, for immutability, a different implementation of object-oriented design, etc. We need like provide glue between these paradigms. Debugging and tooling, from my experience, is quite difficult to debug such application if you have a part in a Python, like a part in a C, part in a Go. Yeah, this is what we need to pay. Cross-platform compilation, yeah, nice in a Go that it's cross-platform. You can do like you have one source code and can build for all platforms. In a C or C++, it's not so smooth, and we need to handle it. And usually it's a performance overhead. If you're using 2 languages, 3 languages, it's not have such nice performance. If it's everything is a one language. Just quick format of interoperability. First, it's like inter-process communication. I will go quickly one by one. Another, it's component-based software, polyglotic virtual machine or runtime sharing. And last one that we mostly focus on, it's a friggin' function call, which is coming from CGO or language binding. Yeah, if you talk about the inter-process communication, it's the most easiest way. You just create 2 processes, one in one language, another is in another language, and provide inter-process communication between these 2 processes. Yeah, most easiest ways you can use like pipes in your operation system, sockets, shared memory, different gRPC, web services. Yeah, mostly it's some standards way. For example, Fuchsia operation system provide like a FIDAL, etc. And then you have a like inter-process communication method. You can define some data format, and it works. This is like a short example. I hope that you see the code. I try to do it like bigger, but it's showing how to provide connection between the Go process and C++. And this is mostly like not real, but close to real scenario. In my case, it was what I mentioned, that we have a like create PDF generator. And yeah, first we investigated a lot of different SDK for PDF, etc. It's cheap and very complex, and we found very cheap solution. So we generate HTML, which is mostly supported by standard Go library, and then convert HTML to PDF. We found like a C++ library for it, and for quick prototyping, we just wrap the C++ library for executable process, and then we create Go REST service, which like input getting HTML as output getting PDF. And I can just quickly go through the code. Yeah, if you looking at the C code, it's very simple. So we compile it as a executable process. We put in some configuration as a command line parameter. Then we are sending HTML as the input, like in a standard input, and as a result, we are sending back as a standard output. And actually, cool thing that we have another channel, which is standard error, which we can use for redirect logs from C++ process to Go process. And yeah, if you need to generate any logs in C process, we just sending it to the standard error. And from Go side, it's mostly simple web service. So we first, we compiled C code, then we run it in from Go process. We run C process. We redirect input parameters, command line input parameter from Go to C. Then we subscribe. Subscribe for standard input, standard output, and standard error. Yeah, standard error, we just in a separate Go routine redirect result from standard error to log. And yeah, we starting web service, we create handler. From request, we are reading body, send body to the standard input, read standard output, and send back as a response. Yeah, this like 10 lines of the code perfectly works. You see that we compiled C project, we run Go project by passing some configuration parameters. Then using CURL, we do a request. I remove it like a real implementation conversion and just create fake one, which just replace HTML tag to PDF tag with parameters. But it's nicely work. As a response, we are getting code from Golang, from C++, and it's just a few lines of the code. Nice and simple. Another, it's a more advanced technology. It's a component base. When you we have a lot of framework where you allow to create component in a different languages and then build your application with this component. Usually it's used like object-oriented model. Component have like own interface definition language. It's usually or dynamical linking to the final application, or it's even started a separate process and use inter-process communication. Component, it's, as I mentioned, language agnostic. Many nice feature like a registry of the component. It need to handle memory management. It's usually done through the reference counting, marshalling of the input, output, etc. There are a lot of good examples of it. So it's the most simple example, it's dynamic library. You can always build and create shared or dynamic library using any languages, and then use this dynamic library from another languages. Another good and powerful example, it's for example COM. It's one of the biggest technology in the Windows world, where you can create COM component using any language, register in a system, and then use it from any place of your application, any application, just by name. It's very easily to use. Yeah, I would like to say it's quite difficult to create COM component because it's many aspects like reference counting, memory management, registration, ton of stuff. But after that, you have like one line of the code, and you can call it from, for example, from Python, from Java, even from Go. Yeah, and from my experience, we create a lot of SDK using COM component. And even right now, when I, for example, working in my Go project, and first setup was in a Windows. We use Windows IoT operation system. And I found that SDK for Windows for data acquisition, it's really implemented as a COM because it's allowed to easily integrate with the many languages. We don't use COM directly. We generate C wrapper from COM and then using like a CGO use the C wrapper. But yeah, it can be even used directly from Golang. Corba, DCOM, SPCOM, CLI, it's many technology. And yeah, very interesting technology. It's like a Functia, function, like it's operation system from Google. It's mostly whole operation system is written at an even kernel as a component. You create component, you register in operation system. It have own language definition of this component. You just create client for any language. It's fully support Go and use it. Yeah, this technology even was used in one of my a map project, like a new version of the SDK. It was not like a create separate SDK for Java, Objective-C, etc. It was used this Fidal language. We just everything implemented in a C++. We provide interface definition language, and you can generate client for any language that you wish. Just small examples. For example, how we can build our C++ code as dynamic library and use this dynamic library even without CGO, just using some syscalls. So we can load this library, find method by name in this library, and call it this method. And it's mostly provides the same experience as we see previously. So now we compile our C++ code as a dynamic library, not executable process, and call it from our Go web service. As you see, 20 lines of the code and everything working. Another topic that mostly I'm not focusing on it, but we have some idea of polyglot virtual machine. When you have a virtual machine which work with the bytecode, and it's many languages allow you to compile to this bytecode. A good example is a Java virtual machine. So all Java family languages can compile to the Java bytecode and execute it. We have the same, for example, for .NET. It's using .NET CLR, like a common language runtime. Good open source project is a Graal VM, which support mostly all VVLM compilers. Because you have use this compiler as backend. This compile the code to the compiler bytecode, and it's provide this interoperability. WebAssembly, why not? So you can compile different languages for WebAssembly and run from one application. And another approach, it's like when runtime, language runtime, allowed to use many languages. For example, we have this in Apple World, when we have a Swift, Objective-C, Objective-C++, C++C, which you can have live in a one code base, and everything just natively compiled and works. I would like to mention that the CGO mostly works the same. So in the same code base, you can keep Golang files, C++, assemble, even Fortran. I was surprised because CGO support Fortran. And when you compile it, Go compiler just understand what file type is, compile it using own compiler into the objects or library, and then linter using result of the compilation of each component and just provide native code. Just small diagram, for example, how CGO works. If it sees that it's a Go code, it's using 6G compiler, it's using GCC or CLang for C++ code or assembly code. For Fortran has own Fortran compiler, and after that, after compilation, you can just have a one native executable application. And last but not least, it's a foreign function interface. So this is mechanism. It's mostly all languages has. where you can call code written in another languages. But usually, if you're talking about the FFI, it's mostly C FFI. Because C is a de facto standard for cross-language compilation, and mostly all languages that I know, like Python, JavaScript, Go, Dart, etc., it's have a support for calling C function from shared library or static library. And yeah, Go has the same using CGO mechanism. Usually it's like a dynamic linking. You have some library which is already compiled, and you dynamically, even statically using it. It has notion of the function signature. You need to understand what input parameter, what output parameter is. Data mapping. In this case, if it's like a CFFI, it has like a standard data mapping, how the type is represented, how it's like a string represent, how structure represent. It's standard. It's like a standard and supported almost all languages. It's not mostly directly. Sometimes you need to some glue code like a GNI, Python C API, for example, to call C++ from Objective-C. You have some intermediate language which called Objective-C++, etc. In a C-lang, you can call CGO. You can call directly. You need to create such kind of the wrapper, and usually memory management, because sometimes it's have a garbage collection, sometimes it's a manual memory management. Everything should be taken into account. And it's just high overview, and I would like really focus on in a Go. And in a Go, we can talk about I would like say 5 mechanisms that I see right now. First, it's like a syscall. It's another is a SWIG, CGO, WebAssembly, which is, I don't think that we'll have a time to discuss it. I will exclude it from presentation. And last one, we have a lot of third-party libraries like GoPython, GoPy, GoLua, which create bindings between these two languages and can easily allow to call Lua from Go and versus. But mostly all these languages using CGO under hood. And just would like to mention that we can have some worked solution, and it's excluded too. I'm not going to really focus on the C call, but sometimes if you operate with the operation system, maybe you don't need to create C or C++ wrapper around it. You can try to use this syscall package to have access to the low-level operation system primitives. It's not cover everything, but it can be good enough for your needs. And before starting creating some complex C code for interact with operating system, we can take a look at this package. It has an extended package in a X directory, which have some extended functionality for Windows, Linux, Mac, etc. This is a SWIG. SWIG is not really focusing on the Go. This is very mature tools which allow you to automate process of creating language binding between C++ and another languages. It's a project, I think it's more than 20 years. It's very matured. And the key feature, you just have a C code, and you generate wrappers for any other language. It's it handles, it's try to handles, or not handles, a map all C++ feature to the language. Yeah, it has sometimes limitation. For example, in Go, it does not support multiple inheritance. It's convert exception to the panics, etc. But yeah, it's like understand how to work with the C++ constructors, destructors, callbacks, virtual function, and generate working wrappers. Yeah, so and also it support a lot of language, including the Go. This is very short examples. Yeah, you have like some C++ class that you would like to use in a Go. It can be a really complex class. It's using another classes, have a callback, etc. You just have this class. And what you just need to do, you need to create interface file which explain what part of this class or what function, what classes will be exposed to another language. For demo, I just say, okay, expose everything in this file. And yeah, we just specify name of the modules for Go that will be generated, and mostly that's all. We just using SWIG minus Go. We describe what language should be generated, what technology we using CGO. We saying it's not C, it's a C++, and we providing this interface file. And all magic happens. It generate your C++ wrappers around this standard C++ class, and also it generate your Go class. And you just can import this module. It's for my case, it's a reader. And after that, it generates all needed functionality. So for example, for config, it generate constructor, config. For each field, it generate setter, getter, then constructor, you can put, you can start. Really take like, you can use just any C++ code, create wrapper, and it just work. Yeah, if you take a look at the code that is generated, it's a huge code, it's a complex code, but it's work without any understanding of the CGO, etc. And it can be pretty good decision if you have a big project and you see that writing own wrappers takes time. Why not? And I know that many Go third-party library using like which is the wrapper around another C++ library, just use this project. It's matured and no issue with it. But yeah, but on practice, I never use SWIG. I always created my own wrappers. And in this, we're using like a CGO. CGO allows you like from Go call C++ function. And also I would like to say and versus. This is like a hello world example. So you have a like C or C++ code. In a Go, you just import C. This is like instruction for Go to enable CGO compiler. Then in the comments before this instruction, everything will be valid C code. You can import, you can just put in all C function. It has like CGO directives, which you can specify some compilation or options, etc. We'll talk a little bit about it later. And then using like this C package can call directly your C function or C++ function. Go has pretty great support of it. It has a lot of sugar code, etc. For example, Go compiler automatically understand that you have a like by file extension that you have a C, Fortran, assembly code in your code base and enable and compile it. yeah, it's like sometimes it's when you just mistakenly copy some C++ file to your Go project just stop compiling and start complaining. And one good thing that it works versus. So you can have your Go project, and you can export or compile your Go project as a shared or static library, which has a compatible C interface. For example, you have your Go project, you can build it as a shared library and use directly from any languages, like from Python, from JavaScript, etc., as C library. And yeah, this mechanism is really cool and allow you to use Go as a low-level language for high-level languages. Yeah, in this case, we just compile your Go project with build mode C archive, specifying whether it's a static library, dynamic library, and as a result, we have a static library in my case, and then you just use it in your C or C++ code. Good thing that during the compilation, Golang not only generate your library, but also generate a header file, I mean C header file, which you can include and use as a library definition file for your purpose. Yeah, but it's not like it has some pitfalls, which I would like to talk right now. First, it's we need to understand what is dynamic library, what is static library, and what is which type of this library better to use. Usually we creating library wrapping. We are not using C code or C++ code directly because it's quite difficult. Cross-platform compilation, type mapping. This is mostly everything what I mentioned during pitfalls using two different languages, error handling and callbacks. If you're talking about the dynamic and static library, in any platform we have notions of the static library and dynamic library. If we build it's a static library, and when we using this static library, it's during the linking process, it's compile whole binary of this static library, not whole binary, but only part of the binary that you are using in your final executable process. And as finally, you getting a self-contained executable process. Usually Go work with the static library, because finally when you compile Go, you have one executable process which you can just copy and use on any machine without any external dependency. From another side, we can use dynamic library, and in this case we are not include the code of the dynamic library to your final executable, but this dynamic library should be provided together with your executable. And yeah, we have some extension for static library, for dynamic library. Usually static library is more preferable because it's remove extra dependency, but in this case it's increased size of your final executable process. Next one, it's creating library wrapper. I not recommend to use a C code directly from Go. It's possible, but it has a lot of issues because your C code it can have some defines and many things that can cause issue in a C Go. That's why usually if you would like to use your C code in a Go, create wrapper for it. And yeah, so it's a small tiny layer between your code and C code written in a C, which provide access. Usually I recommend to create it in a object-oriented form when you divide your components to separate files, each file responsible for one class, where you're defining like a class as a struct, and actually a list of the method which you can provide on this object. Yeah, as you see, for example, this is from real project. I really encapsulated everything, and this is like a header file which is visible from the Go. It's encapsulate all internals. It's not see what. Usually it should have a 0 includes. In my case, it's just some standard includes like a support Boolean type and support long type. I see even like we hide structure definition, so we don't know what in terms of your structure that you provide. And we usually provide like a 2 method. First, it's like a create your object, and another it's a destroy. And yeah, all methods which manipulate with your object, I'm usually starting from the class name. So it's like a task configure, task start, task stop, task read data. And first parameter is always pointer to the task. And another one, it's another parameter to the method. And in C or C++, we already have implementation of this. So it's provide data hiding. We expose only needed feature and only needed data structure. What another benefit? It's really unify memory management. You have always pair when you create something and when you destroy something. And it's help to avoid many issues that we discussed in a 2 minutes. Unify error management. Yeah, in a C++, we don't have any standard or C error management, and you can choose how error should be exposed, and all your methods will be use the same approach. Because if you have like a 3 different C library, each library can have a different error handling mechanism, and you need to handle everything in your Go code. But this allows to unify. And sometimes you even not, it's not only like a 1 layer, sometimes it's required 2 or 3 layers. If you, for example, do binding like a C++ C and then C Go, you create 2 or even 3 layers. Cross-platform compilation. Yeah, so Go provides like a cross-platform compilation, everything compiled to some object code and then platform-specific code. But when you're playing with the CGO, you need to handle it. And good thing that CGO provides many mechanisms for it. One, it's like these CGO directives, which you can specify different compilation parameter per each platform operation system. For example, this is like, again, for my project, as I mentioned, like in Windows, it's using from the co-object to access to SDK. That's why for Windows, we don't need to link any library. But for Windows, it's for Linux, it's like a standard approach when SDK exposed in the library, and you need to link it. That's why we provide like a different compilation parameter for Windows and Linux. Same for Windows, I decided to enable some logs for troubleshooting, and it can be done. So Go have like some like tools, which is like a package config, which you can specify like a configuration of the package, all this parameter, and you just decide what configuration should be used. Like have some tag for compilation. Everything is really powerful. You can enable some preprocessor, disable per platform, and programmatically. Next one, it's types and mapping types for Go types. Yeah, it has pretty good support because initially Go was built on the C. That's why all basic type is just natively mapped. It has good approach for buffer or arrays. Go have a different representation string as C, because in a C, only in a C, you have a strings which have a data, and then you have always 0 byte, which indicates the end of the string. But in a Go, it's a different representation. You can always have a pointer to the data and size. That's why in you need to always do conversion between the C and Go strings. Also, C by default support ANSI. Yeah, it has support for Unicode, and in a Go, it's a Unicode. And when you do this conversion, you should be very careful, because sometimes you can directly convert bytes of the Unicode Go string to the C, and some extended characters, which take 2 or 3 bytes, will not correctly translate to the C. Structures, C structures is available in the Go, so it's CGO does mapping for you, and also it's extend unions, enumeration, even define preprocessors. But actually, this is my recommendation. Let's do not align many of it and use only primitive standard type for exporting. Usually I'm not exporting structure, I just exporting a pointer to the structure, that's all. I'm not exporting like unions, enumeration, it's a good just some constant will be good. Prefer constant instead of preprocessor definition. Minimizing, as I mean, structure, pointer, union, etc. Strings, as I mentioned, and memory management, which we'll talk on the maybe next slide. Next big part, it's error handling. As C, our C++ does not have any standard error handling. And it has like mostly 3 common approaches. It can be return error code. So each function returns integer error, which indicate if 0, everything is good. If not 0, error happens. It can have a global error variable. If something happens, this environmental is set. It's always call it or error no or last error. So and function return Boolean value. If it's error, it's return false. If it's not error, it's return true. It can be some output parameter with error, callbacks, C++ support exception. And as you see, it's a many different types, and you need to unify it. Go by default decided to use last error, and Go have a syntax sugar even. So if you're calling any C function, and it has output parameters, it's a 1, because C function only support 1 return value. But you can always in a Go read 2 return values. First, it will be return values, and another it will be error, which is really will be last error supported by POSIX. But this error is only code. So you can support it, and if you would like to return error from your C function to the Go, before returning, you can set this error no, and get automatically from Go using second parameter of the function. But unfortunately, it's only return code, and if you need more information, it's better to add some context. This is some code that, we don't have a lot of time to take a look, but I usually provide my own last error structure, which has a code.
Looks like Taras has some issue with internet as we have switching electricity. And while we wait, Taras, I want to remind that you have possibility to ask your questions in the chat and in the end of presentation or in the middle, if it will be in time, I will ask all questions in Taras. Okay, Taras, I see you here.
Yeah, 1 second, I will just...
You switch it to another microphone.
Okay, well, give me a second, some technical issues.
Yeah,
With electricity.
take your time.
Because, yeah, sorry, I used two screens and it's not the correct one. Okay. Zoom. Share. Alex, do you hear me and see presentation?
Yeah, I hear you. Could you please switch to your previous microphone? Or not?
No,
If not,
better.
okay, go ahead.
Okay, yeah, this is like some mechanism of the error handling. Yeah, I'm not like really put on the details, but I implemented my last error global local thread environmental variable, which handle like last error in a thread. It's usually code and message. You can create like a set of the function or macros, which easily to allow to set this. And yeah, this is like some kind of the code that I'm using in a C word. I just have like a macros return Boolean result. It means if this function return like error code as a result. But this macros convert. If error code is 0, it's return true. If error code is not 0, it's return false, but also it's put error to non-error and also get context in what place error happens, etc. Also have a tiny wrapper on Go code, which, yeah, if error happens and result of this start task is not true, wrap last error allow me to convert C error to Go error. And usually we have like a really nice error which saying like error happened in a start task and like what underline error, what line of the code, etc. etc. It's very nice for debugging and provide like more information rather than just code. Another part, it's like a memory management and reference passing. First, it's like a main rule that if you allocate some resource in one compilation model, you should always release this resource in this compilation model, whether it's a memory, handler, etc. In many examples, like even for SWIG, it's not follow it. You create something in your library, then you load some C library, get free function from this library, and release this resource. It works. Everything works good on your machine till you're using the same runtime in both compilation model. But it can be happen that you decided compile your library as a static library, and it will include your runtime to the static library. Then you will share this static library. Someone will use this static library, and on this machine it will be different runtime, and it's trying to free. You can get crash. That's why, yeah, rule: if you have some function create exposed from your library, you should always have a function destroy, which release all resources that was created. Yeah, use each language has this RAI stuff when you can have like free some resources if you leave the scope. In Go, you have like a defer. function. So this is a good example. Always when we create C strings from Go string, we need to release it. So we create, and next line it's always defer, free, and we are releasing it. We need to consider that Go it's like a garbage collection library language, and if you have like some Go variable object, and when you pass it to the C code, it will be just destroyed in a Go because it will be no reference for it. And when you will start using again, it will be crash again. Before Go 17, it was like a nightmare with it. You need to always create some global map when you register each resource that you are sending from Go to C, etc. I was surprised why Go only implemented in Golang 17. But now you have in a Go library, you have a handler where you can any Go object convert to the handler. It's some integer value. Then pass this handler to the C, and Go guarantees that this handler will be always active before you manually destroy it. It will be not handled by garbage collector. So for example, if you would like to pass our object to the C, we convert it to the handler, pass it to the C, and if we need to back this handler to the object, we have another function like which convert it, and yeah, you can convert it to the object, or you can use the handler to delete it. Nice feature which allows to avoid tons of the problem. And last one, which I would like to mention, it's a callback. Sometimes, yeah, you need to call Go call from your C code. And CGO for this provide a definition of the callback. So if you have your Go function, your Go function, if you plan to use it from C, it should be only use C types, for example, C int, C short, like C strings, and you can provide like a command before it, like dash export, and name of this function which will be available in a C. Then you have two options. First, it's you can convert this object to function pointer and pass it to the function as a callback. For example, we have some set callback function and we can pass it. Or Go for you generate this underscore cgo export file, which combine all function and everything what Go expose. And you can use this file, just include in your C project and use as a native C function without any magic. And yeah, last slide, I just would like to mention it that another approach is that now Go support WebAssembly. You can compile your Go code to the WebAssembler. It's like you have even a tiny Go compiler to remove some overhead of the garbage collection, etc. It's fully support WebAssembler runtime, so it's access to the operation system, timers, clocks, etc. You can compile your Go to the WebAssembly and even back. So we have a runtime, WebAssembly runtime, which available in a Go. So we have some project like Go WebAssembly, and you can just call WebAssembler from your Go code. Yeah, this is mostly everything from my side. Expecting some questions.
So while we wait questions in the chat, in the YouTube, I will start from my questions. First of all, I surprised to see Fortran like one of supported language in the Golang. And do you have idea why they added Fortran? I mean, in my opinion, Fortran is pretty old language. What sense?
I think that maybe in Google we have a lot of legacy code which is written
Perhaps.
in Fortran, and yeah, because it was a surprise for me. But if you open the documentation, it supports 4 languages. It's a C, C++, Fortran, and Assemble. Interesting thing that it's. Do you know that Go have a like own Go Assemble?
Yeah.
Yeah, it's like for cross-platform compilation, and yeah, it's compiled first assembler to Go assembler, and only after that compiled to the native code.
The second question for me, few weeks ago, as I remember, yeah, I don't know, we have some meeting in the office, right? And I mentioned that PHP, Python is awesome language, like a binding for uh for C libraries, right? And you said that Golang is more easy to use, like for binding than Python. Could you please explain what different? Perhaps you have experience. Perhaps you
Yeah.
made some investigation.
Actually, first time when I start using like a C from Python, it was a little bit nightmare. Because in a Python, you need to, on this Python level, like a Python C, you need to handle reference counting. Each time when you adding some object from Python, you need to increase reference, you releasing, you need to decrease it. And it's really can be a point of the failure. So actually on the first my project, when we try to do it, we do it very careful, but still it was issues. After that, we found very good library. It's a Boost Python, which allow to, yeah, you can just use some C library, which easily create C object for Python. And it will handle this reference counting. It's very nice, and it's helped to resolve our problem with unexpected crash. We have a like pretty complex project. Many reference come to the Python, to the C++, and yeah. But in Go, we usually not care about the reference counting. So as you mentioned, we have just handler. We just register object in a Go, and if we not needed it, we just unregister. And you can do like at the beginning register and unregister, but you not should care about each time when you're using object, you increase reference, and stop using, you decrease.
So, last question from me. Golang for some of the developers is first language, and unfortunately they don't have experience like you with C and C++. You demonstrate different approaches how you can communicate with another libraries, right? You can create COM, you can use interprocess communication, you can make some binding, but what is most easy solution for developers who don't know another languages?
Yeah, as I mentioned, like for prototyping, I always using like interprocess communication. It's really do not use any mechanism for like how to do binding, etc. You just create two processes. Yeah, why I start using it? It's mostly from prototyping. First, we got some library for some data processing, etc. And we need to quickly create some UI or web service for it. and it takes like 1 or 2 days to correctly wrap. It was my experience on the Python. But I found this approach very easily. So I just have like a hello world of this API. I convert it to the executable process, redirect channels, create quickly web service on the Python. Python support very great web UI built in. And in 2 hours, you can have a fully web application which use C library. But it causes some problems because you need to always handle that 2 processes exist. If one process crashes, you need to restart it. It's like some common way. That's why, start with the inter-process communication if you need quickly. And usually, for example, for our report generator, we start with inter-process communication, but it's still in a half year in a product. It works. You do not need, we have plans to do correct implementation and move everything to the CGO, etc. But it works. COM, or COM or FIDAL, etc. This is like a real great technology for exposing SDK. So you create one implementation and expose it, and you can generate clients for any language. And binding, it's like your last choice, because it's like writing some code. You need to really understand how bindings work, how memory represents, how to convert each time from one language to another. It's really in case if you need a tight integration.
Taras, we have question and comments from chat. Let's start from comment. Was from Alexander. Okay, believe you or not, but there are a lot of math-specific science code which were written in Fortran that cannot be ideal to cross compile to or from Fortran. So actually, I agree with Alexander that perhaps Fortran is more specific for some reasons, for some cases, and also question from Taras to Taras from Alexander, sorry. Taras, may you compare from your point of view 2 different approaches to execute dynamic code in the Go? I'm about using dynamic libraries versus built-in plugin engine.
Good questions. So if you're using dynamic library, it's always CGO enable. So you can hack and use dynamic library directly, but it's work very great on Windows, but not good on the Unix environment. I got the question. So it's like a different purpose for it. If you're talking about the plug manager, it's like when you're planning to create microkernel applications, this is architecture. When you have like a core of your applications, and then you would like to create some list of the plugins which can be dynamically loaded, unloaded, etc. This is not really for sharing code, because plugins it's only work go for a microkernel application. But if you're talking about the dynamic library, it's a question of the sharing code, because you create a dynamic library and can use from not only from Go. You can use from any language, from any applications, and all technologies supports dynamic load. So it's like, if you have a Go project, why not use plugins? If you use cross-language development, it's only dynamic libraries.
And for me, I want to add that unfortunately, Golang plugins, I mean native plugins, you can load, but unfortunately you cannot unload. They don't support this feature. Okay, we have additional question from Maria. Can we use Go for compressioning PDF? And is there any point in using Go if you are using PHP? Will there be an sorry, I cannot say this, an advantage in doing so? Taras, my suggestion, you will answer to the first part, and I will answer to the second part. Okay?
Yeah, could you repeat the first part?
Okay. Can we use Go for compression PDFs?
I just would like to understand what is mean PDF compression, because I did like investigation because we need to create PDF reports, and yeah, we have like some paid PDF engine, but if we using like a simple approach, when we convert HTML to PDF, we can have like only two choices. So it's a one good library. It's like HTML to PDF, which written in a C++, but it's used like a Qt framework, which is a little bit old. It's even not recommended to use it. Another approach, if you have like a Chrome or headless Chrome, when you can send to the Chrome your HTML and ask Chrome to return PDF. And this is like an approach. I'm not aware about the compression of the PDF, because this PDF, it's like a format and it's not image. Yeah, maybe in a PDF you can compress image, but it's, yeah, we have like different types of the PDF. So you have like a nice formatted PDF, and you have a text, you can select text, look up for text, etc. Another, if you have like a PDF as an image, and in this case, it's mostly like image compression.
So, why I asked that I will answer to the second part? Because in the Intellias, I'm responsible of Golang, PHP, Code Fusion, and Ruby. And I'm a person who used PHP 11 years, and 7 years ago, I switched to the Go. Does it have sense? Yeah, have sense. But actually, there are two different languages, and they both has own domain. Golang is very, very simple language, and if you're using PHP, and if you are, a regular developer, you will spend about 2-3 weeks intensive learning to switch, and you will have junior level. When PHP is better. Unfortunately, PHP is more strict in some cases. For example, if you want to have server-side rendering, or if you want to use some CMS, if you have some dynamic content system, and it's similar, because Golang also has all this feature, has libraries, services, but it's not so strong. And one additional thing, if you are manager, if you are owner of project and you want to start your project, first of all, you have to think about staffing, and sometimes find a little cheap PHP developer more easy than Golang developer. But my personal recommendation, if you want, okay, you can switch, and also you can combine using Golang in PHP, because there are a lot of projects and cases when we have to migrate from PHP to the Golang, and your knowledge in both languages will be very huge benefit. And additional comments from Alexander: don't use PHP, save your mind. Not agree, but okay. Perhaps you have alternative opinion to this topic.
As usually, so it's a right language for right task. Golang, I think it's a great language for microservices development. Yeah, it has like a very good infrastructure, tons of the frameworks, connection to the database, maybe like some utility development. I know that there are some framework which you can compile Go to the WebAssembly and use in the front end. I know there are such initiative, but yeah, right task. If you're talking about the front end, it's usually JavaScript. Yeah, if you need to do WebAssembler, for me it's like C++, this is Rust, and now I just like SWIG a lot. It's like a great language, not Go, because finally you get like a very huge compared to the other languages bundle of this WebAssembler. I know that WebAssembler right now trying to support garbage collection, and it will help such languages as Go more correctly compile to WebAssembler, but I'm not sure that is right language.
I want to add that one of popular PHP servers wrote runner and write it on the Golang.
Just for speed.
Yeah. So as I don't see any question anymore, in my opinion, we can stop. So thank you for your join. I see we had a pretty good number of users who who was with us, and thus my personal thank you for you. It was very interesting. It was very interesting for me, and in my opinion, this is very complex topic. And unfortunately, most of project on the Golang is more simple. But I hope from now developers will have more tools that they can use in them work.
Like just my comment, so it's like not more simple, because if you take a look at the many Go third-party libraries, it's try actively use like a CGO, like even some I don't remember some web service, etc. It's like have like written in a Go, but sometimes for improved performance, you can build it using like a CGO, and it's using like a C code. For example, now a lot of ML IE stuff, it's like a TensorFlow, GoNum, etc. It's like written in Go, but it's really CGO under hood, etc. Yeah, so it's many hidden, because for example, when I start investigating like HTTP to PDF, I found, okay, we have tons of Go library, but when I start looking on it, under hood, everything is the same. So one is using just CGO, another it's like compiling this project to executable and just run it. Another it's do the same. But yeah, so it's when you start looking on it, it's actively used in a Go world, but it's hidden for a final user of this library.
I absolutely agree with you. I mean, I meant from user perspective. I mean, like when I developer write own binders, or I just want to write own connection to libraries, not not in the situation when I take already implemented binder. Okay. So. Then let's stop our presentation.
Okay, yeah, thank you.